Present Table is a dynamic table designed to foster communication through movement and encourage interaction. The presentation will cover the concept, the design, the technical elements, and the algorithm. Maya Angelou once said, "Sometimes, the hardest part of starting a conversation is simply breaking the silence." This highlights the social challenge which is being addressed by the table's responsive design. So, how can we create a table that fosters communication? This is the main challenge the table design aims to address. Different levels of proximity influence how people engage. Closer distances create personal connections, while greater distances act as barriers. The table adapts to optimize these interactions. Therefore, in order to foster conversation, it is important to foster proximity by using and adjusting distance. A round table was used as the base for the design, as it is optimal for conversation, by introducing concave and convex transformations and repeating the form 3 times. Multiple configurations emerge, increasing adaptability. Additionally, varying table sizes add further diversity to the seating arrangements. Initially, the table is fully extended, an open form that allows easy approach. As people gather, it adjusts to bring users into an arrangement that encourages conversation, then shifts outward again. The connection piece serves as the structural link between the supporting elements. By linking the supports, a foundation is formed for the tabletop. To simplify construction and disassembly, an interlocking joint system is used. At the top, an interlocking joint secures the 3 supporting elements. The table's cover houses stepper motors for controlled movement, IR sensors for detecting users, and rotating pinion gears for motion. The Arduino Mega and MicroDriver are stored away underneath this tabletop layer. IR sensors detect people at each side of the table. A central gear system controls rotation using stepper motors. Three layers form the rotating tabletops. The gear layer for motion at the bottom. It engages with smaller pinion gears to enable rotation. The gliding rail layer for alignment and stability. The fixed top layer for stability. The table is CNC cut from laminated veneer, designed for easy assembly with interlocking joints. I want to talk about the technical aspects and algorithms. We will use stepper motors for the rotating tables. To control the stepper motors, we will also use stepper motor drivers. The stepper motors are placed at the center of the tables, and there are driven gears on the table's edge. As for the sensors, we use infrared, IR sensors to detect people. Next, moving on to the algorithm. In the algorithm, if no person is detected within the range of the IR sensors, the output returns false. If a person is detected, the output is true. There are 3 sensors installed on each table, so the combinations of sensor outputs, for example TTT, TTF, etc., are the inputs for this algorithm. The basic algorithm works like this diagram. The tables start in an extended configuration to attract people. When someone approaches, the tables rotate to a retracted configuration. In addition to this basic algorithm, if there are 2 people on one side of the table rotates toward those 2 people. Now, I will show a video demonstrating the algorithm. The red area is the detection range of the sensors. First, when there are no people detected, the tables remain in the extended configuration. When someone comes to the table, it starts rotating. In this scenario, 2 tables retract, reducing the distance between the 2 people. If another person arrives, the table rotates toward them, providing space for their conversation. If several people come around, tables rotate to retracted configuration to foster conversation. Finally, when everyone leaves, the tables return to their initial extended configuration. However, the direction of the crescent extension is randomized.